All right, hello everyone. Thank you for being here today with us for our webinar, Toubkal Supercomputer, Powering Morocco's HPC Future. My name is Safa, and I will be your host for this session, which is another webinar, part of the Morocco HPC initiative. For those of you who don't know us, at Morocco HPC, we work hard to support high-performance computing in Morocco and also to connect people with different resources and also knowledge. Today, we are very excited to focus on one of Morocco's most powerful tools for research and innovation, the Toubkal Supercomputer, hosted at UM6P. Our speaker is Dr. Robert, who is head of the Toubkal Supercomputer and also an associate professor of computer science at UM6P College of Computing. So Robert has years of experience in computing and research, and will share with us today how Toubkal is driving research and solving big challenges here in Morocco. We'll also have some time for questions at the end, so please feel free to drop them in the chat during the talk or at the end of the talk, whatever suits you. And yeah, let's get started. Welcome, Robert, and thank you very much for accepting our invitation. And now the floor is yours.
Thank you, Safa, for this very nice introduction. I'm very honored and pleased to give this presentation to the audience, and looking forward for your questions. And if I understood correctly, I have 30 minutes. So I will try to be short and direct to the point. So as Yusafa said, the title of the presentation is Toubkal Supercomputer, Powering Morocco's HPC Future. My name is Robert Basmadjan. I'm the head of Toubkal Supercomputer as well as associate professor at College of Computing. So before starting, I would like to give credits and thanks to Ahmed Kassami, who's a professor and a colleague of mine and ours at College of Computing, and also the Toubkal team because of the efforts to prepare these presentations. So let's start with a very basic understanding what is an HPC. Maybe you heard about it. It's high performance computing, or in other words, supercomputer. But let's understand in a very non-technical way. So HPC is a type of a data center, and the data center is a place where it hosts ICT resources. ICT resources stands for information communication technology, like servers, networking devices, and storage devices. And these resources of data center are used, especially in HPC, to solve complex problems. And these complex problems in HPC words, these goes to terabytes, petabytes, zettabytes of data. As you can see, it's a huge amount of, it requires a huge amount of performance. And that's why it's this type of data centers, HPCs, they can provide you results within hours or days instead of getting it done on your server or on your computer that it will take weeks or months. So let's take a very abstract and rough idea about how you interact with this machine, which is known as supercomputer. So to your right, you can see that we have the racks, where on it we have shelves of servers interconnected to each other through a network, and these networks of racks and servers are interconnected to the storage devices. And there is this cluster manager, which is a scheduler. In our case, it's Slurm, whose job is to map or to assign tasks or your jobs to the specific resources or servers. So how you as a user, you interact with this data center. So you as to the left, you send a job request. It goes to the scheduler, which is in our case Slurm, and this is mapped and is executed on the servers, on the ICT infrastructure. And once it is executed and it's done, you get back the results and you analyze it. It's as simple as it is. Before delving into more details, let's understand the difference between cloud computing and HPC. Maybe you have heard those two terminologies, and maybe it's not clear to you what the difference is. And I will not spend that much time, very quickly. So let's start with the cloud. And we heard about cloud computing, and examples are like Amazon Web Services, Google Clouds, Microsoft Azure, and Alibaba Cloud. And we also have co-located with Toubkal Supercomputer, we have Atlas Cloud Services, which is a purely cloud-based solution. So what is it? Again, cloud is a type of a data center. in which is a different, it has a different, let's say, it has the same infrastructure in the sense that it consists of servers, networking devices, and storage devices, but it is based 100% on virtualization. So what you have is that a machine will be virtualized, and you as a customer, you come and get a part of this machine, and you get your resources in a sort of a virtual machine. For this system to work, you should have a very strong internet connectivity, because the interaction between yourself, which is front end, and the back end, which is a data center, cloud data center, it should be with low latency, high throughput. So the internet connectivity in this respect is very, very important. Pros for the cloud computing is that it's elastic. You can get, for example, there are lots of business models where you pay and you grow as much as you pay. So it's elastic, right? You can start with a small virtual machine. You can make it bigger and bigger and bigger. You have a reduced capex, capital expenditure, and everything is virtualized. Your resources are virtualized. The cons or disadvantages of the cloud computing is that as it is highly based on the internet, so if your connectivity is not that strong, the connectivity could be a bottleneck. You might have also security concerns, and you might also have some latency issues. So let's go to the HPC or supercomputer. As you can see, now we have cluster of nodes. And in these nodes, we don't absolutely have virtualization. It's only physical machines. And whenever you submit a task, as I said, the task scheduler or the cluster managers, the scheduler submits these tasks on the resources, and you own only these physical resources: CPUs, the memory, the hard disk, etc., etc. So the first supercomputer was built in 1964. This is CDC 6600, and it had at that time 3 million calculations per second. Just to get an idea about today's our mobile phones, they can do things much faster than this, but we are talking about something like a technology of 60 years old. Then Frontier came in 2021, which was the fastest supercomputer, which had 9 million AMD CPU cores, and it provided 1,353 petaflops per second of performance. And it was just this week, I was just telling to Safa that the new list came, and there is a new leader. So Frontier was the leader, the fastest supercomputer worldwide. And now we have, since this Monday, a new leader, which is El Capitan. Its name is El Capitan, based in US. And this has 11 million AMD CPU cores. And this provides 1,742 petaflops of performance. Now coming to Toubkal, it was built in 2020. We have 71,000 CPU cores, and it provides 3.16 petaflops of per second of performance. The pros of high performance computing, as its name indicates, supercomputers, it provides its main purpose: no virtualization, high performance. So it is the main goal. We have high security criteria, and we can have some redundancy in the sense that you can, because it's possible and it's available for you, parallel CPUs, parallel cores, you can do redundant computations. The disadvantage on the other side is that it's based on one operating system. It's Linux operating system, and mostly it is a homogeneous infrastructure in terms of the hardware. So we might have vendors, servers from the same vendor, and we have a limited geographic distribution because everything is located in the same huge data center. So going back to the specs of Toubkal, it's a supercomputer acquired by Mohammed VI Polytechnic University, UM6P, and this is managed by the College of Computing, which is a part of the UM6P ecosystem. Its installation year was 2020. It first became active February 2021. Its first initial upgrade was GPUs A100s in December 2021, and we are in the urge of also upgrading our infrastructure, and we will be soon upgrading our GPU cores. So please stay tuned to know what will be the upgrades, but it's coming soon, hopefully by the end of this year or the beginning of the next year. From the computer resources, we have 1,000 CPU cores of Intel Xeon Platinum. We have 5 servers with each 4 GPU A100 cards. We have servers. Most of our servers have each nodes 192 gigabytes of memory, and we have high memory servers which goes into 1.5 terabyte of memory. Overall, from the storage point of view, 8,000 terabytes of storage for everyone in the not for everyone, overall in the data center, in the high performance computing, and this is based on the last parallel file system. This is I put it green because this is like related to the greenness. We have 1 megawatt peak of solar energy, which is installed on the rooftop of the data center, which can provide Toubkal its peak generation when it is in a sunny day, 100% clean electricity. So Toubkal currently it's ranked number 1 in Africa, and in this month's ranking of top 500, we are at 318. In the previous ones, we are at 277, and we are currently at the ranking of 161 when we talk about a green 500. So there are 2 lists. Top 500, this is like the muscles, you show your muscles from the performance, and the green 500, these are like performance over the power demand, and this is where we are at the level of ranking of 161. From the AI packages, we have a pretty good set of packages from MATLAB, Anaconda, Pandas, PySpark, PyTorch, Keras, TensorFlow. And from the simulation packages, we have ANSYS, we have MATLAB, we have Quantum Espresso, and many others. So you can see it here. We have a good portfolio of both packages for doing simulations and for AI training models. I will give you some ongoing interesting projects on Toubkal. So we have genomic modeling of endangered African plant species, genome modeling of microorganisms to enhance understanding of soil fertility, processing satellite data to improve agricultural management practices, analysis of meteorological data, this is for climates, and to support renewable energy project integration, hydrodynamic and sediment transport modeling of lagoons and coastal areas, optimization of power and energy in HPC data centers, this is my expertise, multi-phase computational fluid dynamics simulation, this is Professor Ahmad Kesami's expertise, and recently, again, this is my expertise, we're doing quantum circuit optimization simulations, both from the quantum RAM perspective and other quantum circuit points of view. Some impacts of Toubkal. So what we were able to do with thanks to the use of the GPU, we were able to gain 30% when it comes single cell sequencing models. This is the sequencer, and when it ran on A100 GPU. When it requires high memory, high RAM with our high mem servers, we were able to run UNet models that require more than 300 gigabytes of RAM per node. And with respect to the high CPU usage, we were able to reduce the computation from 1 month to 5 hours of plasma discharge simulation on a 3D model using 2,000 parallel CPU cores. How to get access? As you can see upstairs here, I put in the title our webpage, so you can go there and everything is well documented, but I'm going to go here step by step. First of all, who's eligible to get PI access? Currently, it will change in the coming let's say months and year, let's say, but currently it's Toubkal, you become a PI access if you are in the UM6P ecosystem. What does this mean? You are eligible to request for an PI access if you are a professor at UM6P, either assistant, associated, or affiliated. Or you're leading a team of at least 2 researchers, or you're heading a research institute where it gives you all these 3 possibilities. It gives you the eligibility to become a PI. How to do this? You go to our webpage, toubkal.um6p.ma. Then get started, then you have request access, then it falls down to this Jira account. Again, I'm jumping a little bit about some steps, you might be required to do, if you don't have an account in Jira, you have to create your account in Jira. Once you log in, you go to this page, and once you go to this login page, you go to the request Toubkal account, and then here you can see that you have the three options: internal UM6P, external user, and the new PI access request. So if you are PI access, you wanted PI access, you click on this, and there's a formula you have to fill in: your name, your family name, your email address. Very important. These are must. Everything with red asterisks, it's a must. Small description of the project, your departments, and terms of use. You agree on them, you submit it. So what happens in the background is that once you submit it, it goes to us, to our team. We study the case. We first of all do our preliminary check. Is this request coming from the UM6P ecosystem? If yes, does the requester satisfy the eligibility rules? If yes, then it becomes very quickly, we approve it. Actually, it's me, they approve it. And I mean, the average time, it will not exceed more than 1 day, 1 to 2 days, unless if there are certain things that we need to dig deeper, and then in that case, we need to it takes more time, but usually within 1 day, you get the approval, and if you satisfy all these eligibilities, you get an as a PI access. Now for regular access, those are, for example, if you're not a professor, but you're not leading a team, and you still are eligible to get an access, but in the UM6P ecosystem. Okay, so who is eligible? First of all, there should be an endorsement, approval of your PI, stating to us that yes, this person is eligible to access Toubkal resources under my projects, to whom I'm the PI. So eligibility for regular accounts: you are interns, PhD students, postdocs, research associates, research engineers, and UM6P students. Now, if there's a small, let's say, not a trick, an information, this doesn't mean that if you are not an UM6P email, if you don't have an UM6P email address or UM6P ecosystem, this does not mean that you cannot access Toubkal. You can access Toubkal, but you need to have a collaboration with a professor who is a PI in Toubkal, and in that case, you will get an external EXT email address of UM6P, and you can get an access to Toubkal. And this way, we encourage external collaborations between UM6P professors who are PIs, who have access to Toubkal, and with the externals, being in Morocco, being in the US, being in Europe, wherever you are, just create these collaborations, and then you will get, after the endorsement of your PI, then you will get an access to the resources. How to do it? Again, same procedure. I will do it very fast. Toubkal um6p.ma, get started, request access. You go to this Jira login and accounts. You click on it, request Toubkal account. And in this case, now you have to do it internal or external UM6P user. I'm just giving you the internal example, but external is exactly the same. So again, same formula we have to fill in. What is very important: your name, your family name, your email address, and here you have to put your PI's name, the PI's email address, and the project name. What happens? So you submit this, it comes to us, and now what we do is that we don't approve it. We send your request to the PI that you named it, and you say, we ask him, do you approve the request access of X and Y? And if he or she, the PI, approves it, then we approve it, and then it becomes very fast, and you get an access. So here, the approval period, it depends how fast your PI approves and endorse your access. So it depends. If sometimes we've seen that PIs could for some reason can take some time, 5 days, a week or so. But again, this phase is out of our control. Now I'm going to show you how to access it and how to do things with Toubkal. So there are two ways. other SSH the traditional way. And for mobile Windows users, we highly recommend to Mobextran to use it. It's a user-friendly SSH framework where it allows you like in a very friendly user interface to interact with our supercomputer. Or we have another web-based interface which we call it on demand, where it's with this, and I'm going to show you on the coming slide. It creates you as a virtual environment in which you have you assume that this is like your computer desktop where you are interacting with this desktop, submitting jobs in the background with this huge machine named as Toubkal Supercomputer. So once you have created your login, once you have accepted as a regular user, you have to sign in with your UM6P email address, the password. What happens here is that once you do this, there is a two-factor authentication where you have, again, for more details, we have this GitLab documentation. Everything is clear. You have to download TOTP authenticator where you get on your mobile phone a code. It's a one-time password. You enter it. And then, for example, in this case, you get the one-time password, you enter it, and now you're inside the system. So you can see that there are two ways. There are these clusters, and there are this remote desktop. I'm going to show you the example due to time constraints. I'm going to show you the remote desktop scenario. So if you click on a remote desktop, you fall into this let's say form, and you have to fill in your project name, account, and this is you get it from the a command known as my balance. If you type my balance, it gives you all the information, including the remaining hours of CPU hours as well as the project name. So you copy it from there and you put it here in the form. The partition is the compute if you do the computation, and if you do some graphical, you use the GPU partition. So these are some details that I think at this stage it's not that important. Number of hours, number of cores, you can fill it, and the QoS is the default CPU. On this, I'm going to discuss about the different types of QoSs that we have it on the coming slides. And then you launch it. You click on here on launch. It goes in the background. It takes some couple of seconds, and then it creates for you this remote desktop. And then once you click on launch remote desktop, you reach your environment, your virtual environment. As you can see it, you have your storage, your file system, your last system, and then your softwares, and then you can interact with the system very, in an easy manner. So I recommend for those who hasn't done it yet, we have a documentation. We always keep it up to date and describing all different topics about access, submitting jobs, about TOTP, for example, two-factor authentication, etc., etc. So this is the link that I recommend everyone who's willing to use Toubkal first to read all those topics and get some information, more detailed information about how to access it. Some access and utilization. So on demand, this is the link. As you can see, I've shown you the one example of on demand. SSH, it's your username at Toubkal HPC um60.ma. You use one of the terminals to SSH it, and for any support, you can email support-hpc@um60.ma. Projects, it is very important to understand what you are getting per user. So the default project is named as for the CPU. It's the QoS is named as default CPU. So what do you get is that you get per project 10 million CPU core hours. Okay, this is per on a yearly basis, and with the project you get 20 terabytes of last storage, and then per user. So you have a PI, the project, and the PI assigns some users. Per user, you get 64 nodes, and each node has 56 cores. So you can see them. You do the math. It's around 3,600 CPU cores per utilizer, per user. This is, I think, enough resources to run your simulations, to run your experiments. Maximum hours for this is 36 hours, and then it stops. right? The job should stop. And these type of nodes, they have in total 192 gigabytes of memory. So if you count per 56 cores, it boils down to 3.5 gigabytes per core, right? So if your computation requires high memory, then you have to ask for high mem nodes. And these are, as I said previously, 1.5 terabytes of memory per node. Or if you need your project needs GPU access, you need to ask for GPU project. Or even we can have, if you say your job, for example, the student who's doing quantum simulations, each experiment is taking 24 hours, and it has to be done in two rounds or 3 rounds. So you can see that it exceeds 36 hours. So we ask about long queue, which is 7 days, and this is enough for an experiment to be run on this 3600 CPU course. This is a summary of all our QoSs. You can get an idea about, for example, the default CPU. This is the one that you get it. CPU course is, you get 64 nodes. In each node, 56 cores, so you get around 3,584 CPU cores, and this is for duration of 36 hours. Long CPU, you get less CPU cores because you get less nodes, and this is for a longer duration, 7 days. And the large CPU, this is 36 hours, but now you increase, you double number of nodes from 64 to 128. And then we have the GPU ones, and then we have the high mem ones, and you can see it here. We have pretty good structured way of organizing different resources such that everybody is happy. We keep everybody happy, and such that research advances and do experiments, simulations, etc., etc. That's all from my side. I want to do some advertisements on my last slides. We are very happy to announce that on the December 2nd until 4th, we are organizing our second HPC AI Days. It's mainly Professor Ahmed Kassami, who's the organizer. It will take place physically at UM6P campus in Bengurir. The topics to be covered is, there's a very wide of large topics related to HPC. One of them is linear algebra. Another is GPU programming. Another, we're getting an expert from the MATLAB, and he's going to demonstrate, train, hands-in experiences, AI with MATLAB. And then at the end, we also have hackathon, in which we'll create groups. There's a competition, and hopefully you will win the first, second, third places. I think that's all from my side. If there are any further questions, I would be glad answering you.
Thank you very much.
I think I was 28 minutes. Okay,
yeah.
So.
Thank you very much, Robert, for this presentation. I'm pretty sure a lot of people, they were asking a lot of questions about Toubkal and how it goes and what's actually behind the scenes. And this was actually, the goal of this webinar, is to tell people behind the scenes of Toubkal. And you did that perfectly. So thank you very much for all this.
Pleasure.
Thank you very much again. I don't know, Si Imad, Si Hassan, do you have any questions before we move to the audience?
Yes, I have maybe a question. First of all, thank you, Safa, for making this webinar, and thank you very much, Robert, for this clear presentation. So you cover all the parts. It will be very insightful. So my question is, I think several people outside the UM6P ecosystem are asking this question. This is why I will ask it. So how can external users have access to Toubkal Supercomputer?
I think I explained it, but I repeat it again. It's the key here is from the externals to collaborate, to find a professor who's at UM6P, who has an access, who is a PI in Toubkal, and collaborate. It's not just collaboration to get access. It's real collaboration, scientific collaboration, such that at the end of the day, there's a win-win situation, both from external and from the internal point of view. So it's through, at this stage, through collaborations. In the future, this will change, Ahmad, definitely. But at this stage, as we are only open to the UM6P ecosystem, we wanted not to discriminate our external users because we value our external users. And this is the only way that currently we can host externals to use, and there are several, it's not that hasn't been done. There are several use cases. For example, one of the use cases is the quantum simulations. I'm doing it with Finland. And this is where I'm collaborating with Finland, and this is where I'm a PI, and this is where it's on a topic of a research interest, and this is where things are happening. And I can give you some other examples. Ahmed, I think you also have some examples. So my advice here is that try to find real collaborations such that this gives you eligibility to access these amazing resources.
Thank you very much, Robert. I knew the answer, so but I asked just for the participants of this webinar. So my second question is like you talked about like the upgrade of like adding some new GPUs. Could you elaborate more on that? Like just to give some more details.
Yes, maybe. We are in the last stage, so we already did the purchase order. So we are waiting those so we are buying NVIDIA's 800s, and so this is the currently top-notch GPUs, and hopefully by the end of this year or the beginning of next year, we get them installed and we get them operational. And to the best of my knowledge, these are 80 H100 GPUs, which in total gives us 110 NVIDIA GPUs. And then in the next year, we are gathering some financial support, some financial sponsorship, specifically from the UM6P ecosystem. And we are thankful for them. And there's a real project of going to a mid-range upgrade of GPUs. And when I say mid-range, this is like to become some competitive with our competitors in terms of GPUs. But this is still a project that's I cannot promise. We're in serious discussions with UM6P and UM6P ecosystem. It's just about approval of the budget and getting the rights purchase orders.
I have a question.
Thank you
very
much.
I hope that I answered to your question.
Yes, of course. My question, I think the question of many participants. So thank you very much.
Sure, my pleasure.
Sil Hassan, do you have any
questions? Okay. Thank you, Safa, for taking care of the webinar. Hello, Robert. Do you remember me?
Sure. I remember you.
How are you?
I'm very good. How about you? All is good?
Good to see you. Good to see you. This is a great, clear presentation. We know a lot about Toubkal now. I have a question about the ranking, either in the top 500 and in the green list. Like you said at some point, it's actually the first in Africa. Is it still?
We are still the first in Africa.
And then worldwide is like 161, right? In the
in top in green 500 we are at green 500 we are at top 161, and in top 500 this is where the performance takes place. We are at 318.
Okay, and so with the upgrade that you are planning, do you project like to go? What will be the rank? Like, what is the expectation for the rank? Actually,
this is a very nice question. Excellent question. Today, I had a discussion with a couple of decision makers, and to be honest, we are studying whether these upgrades we should do the correction, or let's say the new calculation of HPL, or we have to wait until the next upgrade. So it's a matter of doing the right our homework very well to understand when to contact top 500 to do, because at the end of the day we have to do again HPL now on the GPU cluster, because now it's increasing the GPU, and GPU, as you know, it's performant,
Yeah.
It boosts the performance, especially our GPUs are used for AI purposes. And this is still we are gathering insights, we are gathering methodologies, but this is on our to-do list.
Okay.
Definitely.
Thank you so much, Robert. I will let the floor for
My,
others. Thank you
my
so much.
pleasure.
Thank you. I appreciate it.
My
Thank you.
pleasure.
Thank you.
Yeah,
Thank you,
thank you
Safa.
very much. My pleasure. Thank you. So we have a couple of questions from the audience. So a lady who's asking about PI, but then Seymed answered the question, means project investigator, or yeah. Psisam is saying thank you for this insightful presentation. We have gaming overdose. I'm gonna put the question on the screen so that you can also see it. So they're saying very, very good webinar. As a new PhD student and new HPC user, I really get benefits from this large collection of information. Thank you very much. Just a suggestion, as more UM6P studies from departments within the UM6P, they are not familiar with Linux and system commands to use Toubkal HPC environment. So it would be great if you upload a tutorial playlist on how to use the HPC environment. I actually had this question jotted down, and I wanted to ask you if there's like some sort of training or some sort of like information about how to use the cluster.
A very, very great question. And we have the following things. Those basic access things that I presented it. Imad prepared videos, and it will be soon uploaded on our website so that you get very short videos, direct videos, how to get access. He explained extremely well in a very short period of time, so you don't get confused. It's short videos, how to get PI access, how to get regular access, how to access Toubkal, all these things. Now, with respect to specifics of how to program it, the basics, we do regular workshops. For instance, 3 or 4 weeks ago, we did a specific workshop where Ahmad presented from A to Z, elementary programming, how to interact, how to submit tasks with one of our departments. We do regularly. If there are some requests, send us to us. We will study it, and we are planning also to have such type of service, though it will be paid service. Such that, because our team is going and spending, like Ahmad spent 6 hours only for training, we will soon provide such type of services, but at this stage it's open. Send us requests, we will study it, and we'll definitely reply to a request if we see it is needed. But again, I encourage that you participate to the HPC AI days. There again, I think Ahmad and the team and the crew will go in details, and we'll show you, demonstrate you live scenarios, how to submit tasks, how to do programming, GPUs, parallel programming. So I highly advise you, if you are a PhD at UM6P, use this opportunity to come and attend. And it's a physical, thanks God, we don't have any Corona anymore. It's a physical event. Come, and we can meet you. We can even discuss if there are any other issues. So we have different types of, let's say, workshops, trainings, and one thing I forgot, we do also webinars regularly. For instance, 2 weeks ago, we did a webinar with PhD students from the medical school. She demonstrated her experience of Toubkal, which is amazing. Her programming machine learning models using Toubkal, and how and she demonstrated results. And she's willing to go, because there were requests asking, can you tell us how you submit jobs, like the example of like the question, how to submit jobs elementary, and she's willing to give webinars, a webinar for that, and we will be organizing soon a webinar. So webinars, trainings, workshops, yes. So those are the things that we're trying to improve over the time. Because Safa, and sorry for the interruption.
No, that's good.
Toubkal grows. Toubkal grows with its users. And users for us is our jewelry, right? We have these resources, and if you don't use these resources, it's a shame. So Toubkal will go to Toubkal 2, Toubkal 3, hopefully, with the growth of our users. So users, our users, it's like our customers, right?
Yes. Yeah, yeah. I was gonna say also about the HPC and AI days. It's very good opportunity for the participants to meet the team, actually physically meet the team, so that they can ask all the questions that they have, and yeah, the team will always be happy to answer their questions. We have another question from Wadia. I believe the hardware is mainly made of Intel Xeon CPUs. Are you using the one API ecosystem for it? And do you have or need runtime library engineers with relevant experience in it?
Definitely, we have all the necessary engineers, and for the software supports. And I have a good news. We have an external consultant who is an expert related to runtime libraries engineering, and he
Okay.
is his job is to um, ease the life of the programmer developer from the libraries point of view, from the runtime point of view, optimization point of view, and he's coming from Shaheen 3. So this is
Oh, okay.
it's an excellent news. So we have him as an excellent consultant, and him together with us, we will contact we're compiling now a list of our top users, and we will be contacting you very soon, and we will interview you, and we will discuss with you, ask about what are the problems, how we can improve it. So things are coming, so be patient please, but in the coming weeks, or let's say months, we are working on it to make even the runtime environment, the libraries, even better. I know that it's not the top. I know that there's a lot of room for improvement, and that's why we got our consultant, external consultant from Shaheen 3, so that the person helped us. I will not like to anonymize he or she. The person helps us so that we go to the next step, and our vision is together with the person to go from Toubkal to Toubkal 2. So this is our mission.
Yeah, that's already looking really good. Yeah, from now. Another question from Anas. Thank you for the great presentation. It was very clear and informative. I'd like to ask, what is the utilization percentage of the Toubkal supercomputer, and is it stable over time?
Good. So GPU queue is almost 100% utilized. So I have like complaints from, because GPU queue is very small, and we have people using AI and machine learning. So the GPU queue is mostly occupied. Now coming to the CPU, because we have 71,000 CPU cores, and still and this is again one of our mission, to have this HPC culture. Still, this HPC culture is not at the UM6P wide, how can I say, matured. The CPU utilization is pretty stable, and let's say in the last 6 months, it is ranging between 35-40%.
Okay.
And our objective is to increase it, to boost it 60, 70, 80% through the improvements, through engaging more users, more departments, and through improvements.
Yeah. Yeah, actually the HPC culture is actually what we discussed also before starting the webinar. It's like we need again this culture. We need people to know like why HPC and how to use
Correct.
HPC, how to do HPC actually.
Correct.
Thank you, Anas, for the question. Another question from Abdul Malik. Thank you very much. I would appreciate it if there is an online or upcoming version of Prof. Ahmed's workshop, since we are doing the same. And I think he has, since we are doing the same research in CFD field. Thank you.
So I think Ahmed can answer to this.
Ahmed can take this.
Yes, yes. Inshallah, maybe next time we'll try to plan something online for some how to use the HPC platform or something like that.
Okay. Another one last question from Wadia. What role does Atlas Cloud Computing Company play exactly? Does it own the supercomputer? Does it have priority over it?
Okay, I have to be pragmatic here. I have to be. I will answer the question, but maybe not go into details. Atlas and Toubkal are co-located. This means that there is a huge data center. One part is we call it data hall. One data hall is Atlas Cloud Services, which provides all this. It's a cloud. It's only it's a cloud data center. It's provide cloud services, and the other data hall. It's just another. Let's say it's not another building. It's the same building, but in a different location. It's Toubkal. So Atlas Cloud Services, they provide us some services in terms of what? In terms of, for example, energy computation, in terms of some security clearance point of view. But Toubkal, it belongs to UM6P and it is managed by College of Computing. So I think I cannot be clearer than this, right? So
Yeah,
this
that's
is
clear.
like we are not competitors. Everybody has its own, let's say, type of users. We are HPC high performance computers, which are used for scientific purposes, scientific computations, mathematical computations, which does not go in line with cloud computing model. Cloud computing is like virtual machines, deployment, but I think they are complementary to each other. So once you get your machine learning, for example, your machine learning models, you cannot deploy it in Toubkal. You need somewhere to deploy. And this is where Atlas Cloud Services comes into the picture. But again, these are two separate entities, which we work very collaborative with each other. We have common projects together. Yeah, that's all I can say about those two entities.
Okay. Sam is saying all the information is valuable and clear, and the projects look very interesting and promising. Thank you for everyone who participated in this webinar. We have one last question from Anas. He is asking if Toubkal is used for defense purposes.
No. Let me understand. Military.
Anas,
Defense is a security thing. We have all the security measures.
Okay. Anas, would you please clarify? Because we're not sure we understand.
We don't have military projects.
Okay. Yes, so I think he means military.
We don't have military projects.
Okay.
Unless, correct me if I'm wrong, Ahmad. We don't have, it's like, we don't have military projects.
So we have department working with the military. I think they have some projects, but it's but I don't know if they are using like Toubkal or something. But there are some projects with UM6P and military department.
Good. I'm not aware of that military projects running, executing on Toubkal. There might be some projects. That's why I said I'm not I'm not aware. But to the best of my knowledge, there are no big computations coming from military defense projects.
Okay, that's clear. I hope this answered your question, Anas. I think enough questions for you, Robert. Thank you very much for taking all the questions.
My pleasure.
It was really amazing. Like the presentation itself, your answers for the questions, and all the details that you provided. It's really, really amazing. Thank you very much for accepting our invitation and for the time that you gave us for our audience and also to prepare for the webinar with all the details. It was truly amazing. Dr. Imad, Dr. Hassan, do you have anything to add before we wrap up?
Well, just thank you. Thank you both of you.
Not for me. Thank you very much, Robert, again, and thank you also, Safa.
Thank you.
This webinar.
Thank you very much for everyone who attended the webinar. And yeah, you can always get in touch with us on our LinkedIn page. If you have any questions, if you have any suggestions, we will always be happy to take them. Thank you again, Robert. I cannot thank you enough for your time.
One final thing, stay tuned. Use our website, stay tuned. Yes. We always regularly and also participate to our webinars. We send around webinars. We want to have our external database as well. So if you can help us, Safa, in having our some of you maybe some of your database, you can send us to us so that we diffuse because our database is a local one. UM6P. I would like to have an external whenever we organize webinars, so external audiences can also attend, and it's open for everyone. And this is where it lacks. If you can help us in this respect, I think it will be perfect.
Yeah, that would be actually great, and we can always do like promotion through Morocco HPC. That would be also amazing. We can always do that. Yeah.
Awesome.
Perfect. Perfect.
Thank you so
Thank you
much.
very much. Thank
Thank
you.
you.
Take care.
Bye.
Bye bye.
Bye.